Um, Real-time proving is here. Who has heard that? Can I get a show of hands? Okay. And who believes that in their little heart? Wow. Okay. 3 people, just for your information. Um, no, I mean it's true. There's like proving performance has increased. It's getting realistic to build at least prototypes using it. But as client developers, as infrastructure providers, like service providers, this is the right time to start asking a lot of questions in order to figure out how do we make this thing work. And I have to warn you a bit in advance. I've had a lot of conversations this week, so there's probably going to be a tinge of pessimism in this presentation. But the goal of this presentation is not to be an essayer at all, even though I will definitely sound like this at times, but to really bring up the questions so that we can start having the right conversations. Quick reminder, I mean, I assume everybody knows here, how does a client work at the core? I mean, of course, there's a lot of heavy machinery around this, but we receive a block, we receive the state, we run the state transition function through the EVM, we get a post state. Now, we introduce ZkVMs, and there's a lot of mathematical mumbo jumbo that scares people off, but the principle is very simple. You have an input, you have an output, and you have the ZkVM that will do whatever it takes to prove that if you feed it a program with this input and this output, the input indeed corresponds to the output when running the program. So everything is validated. And this is quite interesting for validating roles, at least, because as we will expand, it allows, like, it brings a lot of advantages, and it also brings a lot of complications for anybody who's not a validator. So this is what the new diagram happens to be in ZkVM world. I made some design decisions. You could argue that you don't really need to run the same old thing before, but yeah, this is the choice I've made for the sake of simplicity. So it's basically the same principle here, except on top of that, you add, like, as an output to the block creation or validation transition function, you output a witness that corresponds to the pre-state that is going to be used during the execution of ZkVM. And then you run in the prover a ZkVM, which is typically emulating a specific architecture. It can be MIPS, can be RISC-V. This is the most popular at the moment. It can be others, if you've heard of LeanVM. And then on top of that, the program that it emulates, the RISC-V program it emulates, is the EVM compiled as the target architecture, RISC-V, MIPS, you name it. And then on top of that, the EVM itself is emulating the contract. And the output of this is a lot of traces, and then it's fed into some polynomial magic. And you also take the post state to make sure that, like I said, the input and the output match, and you get a proof. So it's a bit more complicated, but not that much. So when you are a validator, it's great, right? You don't need to re-execute. You have the proof that the execution did exactly what you expected it, so you can just take the new block, you can take the post-state root, and you say, this is the new post-state root, this block is valid, I can accept it. I don't need to store any state, I don't need to store, I mean, maybe I need to store the blocks, but not as much either, because I know from, I can just keep the header chain, basically. It's great, I don't need to sync. Sync is a pain. I can create as many nodes as I want. If I want to start doing DVT or things like this, you know, like load balancing, whatever, I can do this. If people might remember this this post by Peter Silagi around the last DevConnect, which was about, I think he called it true client diversity, where a client would produce a witness to be able to re-execute that block, and then you could verify like you have a main client, which at the time was Guess, maybe today would be Nethermind, and then you would take that block, that witness, and re-execute with the stateless client version of Guess, of Rest, of whatever. So you could do very simply and very cheaply. You could do client diversity inside your own machine. It's the same thing. You could do that. You could also have prover diversity. All you need to do is have several provers, and indeed we want to have that because we want to be able to make because producing proofs is very expensive. We want to make sure that if one prover defects, we have backup plans. And then I'm gonna skip the KOVAN because I don't have as much time as I thought. Now that was the benefit. Let's go over the doom and gloom. This is great for replayable blocks, but that means, and that was a fear that predates the ZkVM, if most nodes on the network are validators, and if those validators do not keep the state, who's going to provide the state? Big question. Because if you don't have the state, you can't sync. If you can't sync, you can't have new joiners. That's a problem. And on top of that, if we want to implement other scalability tricks like state expiry, not only do you not find the state anywhere, but even the state that is available is not the complete state. Bit of a problem. And incidentally, at least in the models I've seen, the block producer is also the prover, which means that this is the end of home staking. It costs quite a lot of money to produce a block. If you're a home staker, you're not going to have that. You don't have a 10 kilowatt power line. You don't have 16 GPUs at home, or you're the hell of a gamer. Good for you. But yeah, that's not realistic. Yeah, so there's this website, I should have given the link, sorry for that, eastproof.org, that produces some numbers. So they're not, they're not lying about it, they're just being realistic, and those numbers are actually a lot better than they used to be even 6 months ago. But you can see that the latency is an average of 49 seconds for producing a proof, and the median is 7.6. This is where the real-time proving comes from. 7.6, that means after producing a block, you can fit most blocks, the proof of most block, inside the 8 seconds that you have left. But it's slow, it's expensive. If you take this number, that's 50K a year. And by the way, I'm not exactly sure where this comes from. I suspect it's more expensive, but that's just my opinion here. But yeah, 50K a year, and that's with the actual numbers. That means block gas limit around. I mean, if you look at most blocks on EtherScan or OtterScan, of course, that's they're around 30 million. So what if you crank the gas limit to 60 million? So, yeah, this is to explain the problem a bit more. I'm going to do a bit of walking here. So the green, this is a slot, right? You got 4 seconds, 4 seconds for block production, 4 seconds for propagation and attestation, and 4 seconds to relax. Now, in the new model, you still have 4 seconds for block production because, builders still want to provide the best block they can. They can play their timing games, they can do everything. And then you have the proving that starts, and 3 weeks later, you do have the propagation plus attestation, which is very small, right? And the good news about this is that if you run this verification, it doesn't matter how many transactions you had in the block. This is pretty much the same time, which is where the scaling comes from. Because if you go back to 1985 when you produced that block, you could double or triple or quadruple the amount of transactions you put in that block. The time to verify is exactly the same. And one last thing I wanted to talk about is what's called the conjectured. Sorry, there's a lot of conjectures in that thing. So even the mathematical foundation of that thing are a bit shaky. Because the whole, all those numbers, from what I understand, could be wrong. Prove me wrong, please, if I am. And those were assuming that there was a conjecture. I think it's called the proximity gap, right? Conjecture, thank you. It got disproven, so we don't exactly know how much more, how much slower it needs to be. But if we want to maintain the security, the proving is actually needs to slow down. So once again, this is not a terminal thing. We just need to make everything faster, and it's happening. No worries about that. But yeah, it's still, I mean, at least I feel that there's still a lot of work ahead of us. How much time do I have? I think, okay, thank you. So I'm listing all the problems. I promise there's a happy ending. There's the sync. So of course this is not the arrogant style sync. It's more like the snap sync of Geth. But the idea is that you have a boot node and you have nodes over the network, and in theory you just connect to every node on the network and you get a bit of data from everybody. Kumbaya, you get your node synced. In reality, it's not so even. Some nodes, like the boot nodes, are the ones that really get hammered. And in this future, potential dystopian future, this gets even worse because the request to sync becomes so heavy that the boot nodes dies and no one wants to run one because it's just too expensive. And then there are people storing the state privately, but given the fact they don't want to become like a regular boot node, they just serve their friends and that's it. And then, well, if you want to become a competing operator, like if this node starts misbehaving, like let's say it's a producer, he starts misbehaving, well, you can either start your own gaming rig, or you just have to accept whatever change they want to force on you. So that's the question: who has the state, right? If it's like this is a centralization pressure that we need to take seriously and start considering. So because if the state becomes more centralized, like I said, you have potential extortion, permanent loss. Those people can actually lose the data. Censorship, they can decide, well, I'm not going to serve you that state, and yeah, that's nice, this little fossil protocol you've got, but once again, I won't be building blocks for it. So if you want to have it, good luck. So we started thinking, and my team started thinking about this. I have this link to Carlos's article about OOPSI. I'm trying to remember because initially that meant something else, but it's opt-in ownership of partial state of interest exclusively. Yes, that's a bit convoluted, but that's exactly what it means. People have only part of the state, and they share it via SnapSync. So this is one avenue we're exploring to achieve this. And the last problem I want to talk about is proving the state. I mean, it's very connected to the other one. But the execution proof provided by ZK, it's not the silver bullet. Sometimes you do want to have the state, and you do want to have the proof that it belongs to this state root. And there's a lot of applications that come to mind, like wallets. Wallets are not going to; they have no need for an execution proof. They just want to know that this user's wallet is indeed in the state and having this value. dApps, RPC, everybody, and of course sync. All those things, they actually need good old MPT proofs. And so what is to be taken out of this slide, if you are an RPC provider, please, or even a dApp or a wallet, please, please, please stop trusting. Prove everything you send on the network. And then let's be, like the risk is that the burden of state providers will increase because proofs are expensive to generate. But we do have mitigations, and here it is a shameless plug because most of these EIPs are from my team. Yeah, the first one is code chunking because the proofs are large owing to the chunk size, the code size. So that mitigates this problem. It removes some prover killers. So the 3 weeks, like I was talking about. The state tree change, we could switch to a binary tree. That makes the proofs smaller. There's EPBS, which is slated for Glamsterdam, so very good. Meaning, like, it's less of a problem if the proving lasts, fills the whole slot. And then there's this thing by Rig, rainbow staking, which I'd like to expand on because I think it becomes very relevant right now. And the idea is to reward people serving the state to make sure the state does not disappear. So unfortunately, we lost Portal Network, but that's I would say that's okay in the sense that they did not have an incentivized way of proving the state. At least they didn't have it at the time of their demise. But yeah, we need something like that. And maybe we can think of EL sync committees. We can, of course, like those hearts, once again, shameless plug. Oopsie, state expiry, this is what we're working on. And repricings, we're working on that with Rig. Repricing being trying to slow down the growth of the state to make sure we don't fall off the cliff just like too quickly. Okay, missing the last slide. Okay, no. There's a QR code I'd like to show, but okay, why not? So we're going to, like I said, the goal was to ask questions. We want to not just ask the questions, but try to answer them. So we're going to run a stateless summit at EthCC in Cannes next year. Come, it's not going to be as expensive as last year, and it's going to be a lot of fun. Cannes is a very nice place. Some of those French people are actually nice. And so if you want to register or if you want to have more information, this is the QR code. And please come help us solve those problems. Thanks.
Excellent presentation there. A little bit of a speed run through it, and that actually left some time for some questions here, believe it or not. So let's, if we could bring up the questions here. Let me ask the first one while it loads here. What can we expect to see from ZK proving in 2026?
Nice demos. Honestly, that's, okay, that's my opinion once again, but I think we're not anywhere close to a production-ready system. So you will get very impressive demos, which is nice, but I don't expect much more.
Okay, and then let me ask the next one here. How will home validators running a ZK EVM ensure censorship resistance or participate in fossil without execution state or mempools?
Yeah, that's the problem. That's, yeah, stateless summit, come. But yeah, it's going to be difficult to achieve for sure.
Okay. And let me see if I could slip this last one in here. Similar to proposer-builder separation, what's your take on having proposer-prover separation?
Great idea, but in my view, impossible to implement. Okay, not impossible, but then comes the question, if it costs 50K a year to produce a proof, you need to incentivize those people. I like you guys, but I'm not going to spend 50K a year just to provide you a proof for free. So we need to create some incentive, design some incentive mechanism in the protocol. They don't exist at this time.
Excellent, excellent. Please, another round of applause for Guillaume.